Students, good morning, good evening and good night. Depending on which time you are going to observe this lecture. In this lecture, we are going to discuss again a very important topic in this redox reaction chapter. It is the 6th lecture. In this lecture, we will discuss how we can able to balance the chemical equations of the redox process. There are basically two ways that you can able to balance the chemical equation of the redox reactions. Number one, that is the oxidation number method. This method is based on the change of the oxidation number of the reducing agent and the oxidizing agent. Another method that is also a very good method, that is a useful method that you can use it, that is the half reaction method. In this method, what we will do, you have to split the reaction into the two parts, that is the oxidation half reaction and the reduction half reaction, and you have to balance all those half reactions and then you come to the total overall balance equations. So in this lecture we will going to discuss the oxidation number method, by how we can able to balance the chemical equation of the redox process in this method. So heading of today's lecture is the balancing by oxidation number method. Now we have to consider the reaction for the acid medium and also the basic medium. So what we will do, half of this board we will use for the acid medium and half we will be use the basic medium. So here we will consider a reaction which is in acid medium, and that we will consider the potassium dichromate. The acid solution reacts with the sodium sulfite to produce the chromium ion and the sulfate ion. So what is the first thing that we have to write? The ionic equations, right? This is ionic equation. First we will write that we will write the ions. It is the dichromate ions. This is dichromate ions plus the sulfide ions, and this is in the aqueous medium. This is also in aqueous medium, and it will produce the chromium ion. It is also in aqueous medium, and plus SO4 2 minus sulfate ion. It is also in the aqueous medium, and you see it is in the acid medium. The reaction is going on the acid medium. This is K. Mukherjee, the Science with Mukherjee sir YouTube channel. So here the first steps, that is the when we are going to balance by oxidation number method, we have to understand, we have to recognize which element is the oxidation number has been changed. The oxidation number of whose elements have been changed. For that we have to determine the oxidation number. If you calculate this oxidation number, oxidation number will be plus 6, because 2x, suppose the chromium, oxidation of chromium, oxygen have the oxidation number of minus 2, that will be minus 14 equal to minus 2, so x it will be plus 6. Here sulfide ion, that we calculate, that it will be plus 4. Then the chromium ion, it is a plus 3 charge, those oxidation of plus 3, and the sulfate ion, that will be the plus 6. So we now understand the chromium ion and the sulfur in the sulfide ions undergone the changes. Changes means which type of changes? First, that we will write the identify the element identify the element whose oxidation number has changed. Whose oxidation number has changed. Oxidation number has changed, right? So here what we find, the chromium and the sulfur in the sulfide ion changes the oxidation, and that is number two, that is the second step. We have to identify which is the oxidizing agent and which is the reducing agent, and also we have to identify the total change in the oxidation number. So we can write here so here you can see the oxidation number has been changes from 6 to 3. So we can write this is basically when the oxidation number of the species is reduced. Here is a reduction, you can say it will be the oxidizing agent. Oxidation number changes mean that is reduced oxidizing agent. So we can write it is a oxidizing agent, right? Oxidizing agent. And here you can see there is per atom, there is a change of the oxidation number is 3. So there is here 2 chromium atom. So 2 chromium atom means total oxidation number change is total decrease, you can say. Total decrease in the oxidation number is 6 because per atom it is 3. So what we will do, we will put these 2 here. There is a 2 chromium atom that we have to, for this 2 chromium atom you will see that is total 6. Total decrease in the oxidation number is 6. Another equation, that is the sulfite ion is being converted into the sulfate ion. Here you can see the reducing. Here you can see this is the reducing agent. This is reducing agent because its oxidation number is so sulfur in the sulfide ions is +4 and here sulfate is +6. So reducing agent and total increase is 2 because you can see there is a 1 atom is involved here. Third step, that is we have to now total decrease and total increase we have to equalize. Now we have to equalize the total increase is equal to increase in the oxidation number, increase of ON is equal to total decrease in ON. Total increase in ON and total decrease in ON. So for that what we will do, here increase is 2, decrease is 6. So we want to make it equal, then we have to multiply with a factor, that is the 3 with the SO3 and SO4. So we can write this total equation, we can write now that 2 minus plus we have to multiply 3 factor for making it a same. Total increase in the oxidation number, here total increase is 2 only, total decrease is 6. So we have to multiply with 3. So 2 minus, in the right hand side it will be 2 Cr3 plus, then 3 SO4 2 minus. Right? Now what we have to do, there is, you can see the reaction is going on in the acidic medium, and as you can see the charge in this left hand side and right hand side of the reaction, you can see reactant and the product, you see there is a difference in the charge. Here in the left hand side you can see that is total charge is -8. You can understand easily that is -8 charge. Whereas in the right hand side it is 0 charge. So there is a charge difference, and as it is in the acid medium, what we will do? We will make the difference in the charge equalize in the charge by putting the H plus ion. Putting the H plus ion. How? That total 8 minus 8, you have to make it 0. That for that you have to put 8 H plus ion here in the left hand side, and then you can see the charge will be same. Okay. Then fifth, that we have to balance this H plus H hydrogen ion by putting the required amount of H2. See, here is the total we have add 8 H plus ion. So we have to add in this step, that is how many molecules, water molecule we have to place, because it is 8, so you have to 4 molecules we have to add. Four molecules we will add. Yes. Now we will count the chromium atom. Chromium atom is 2. Oxygen you can count. Here it is coming 9, 16, and here you can see total 4, this is 14 and 4, 16, and all the things is balanced. Now this 5 in this equation is now balanced. Okay, so what we do? First we have to calculate the increase in the oxidation number or decrease in the oxidation number. Accordingly, we have to identify the reducing agent and oxidizing agent. Then you have to calculate the total increase in the oxidation number, total increase in the oxidation number, and total decrease in the oxidation number. Then you have to make it equal by putting a suitable integer that we have done here, and after that we have to, as this reaction is carried out in the acidic solution, that we have to balance the charges. And what we find, actually there was a 0 charge in the right hand side, and the left hand side was a -8 charge, that we have make the charge equal by putting 8 H plus ion, and after that we have to balance this 8 H plus ion by putting this 4 H2, and after that the reaction is balanced. Okay, now we will discuss on equation the basic For the basic medium, we are taking a reaction, redox reaction, and its chemical equation is permanganate ion, MnO4 minus MnO4 minus, this is permanganate ion in the aqueous solution. It will oxidize bromide ion into the bromate ion, and it itself is reduced in the manganese oxide, the solid state, and bromate ion. So this is the chemical equation for this redox reaction, where permanganate ion oxidizes bromine into this. So first what we will do, this is the same thing. We have to identify the element whose oxidation number has changed. Here we have to calculate the oxidation number. We will find the oxidation number of manganese plus 7 and bromine is minus 1. Manganese here 4 and bromine you calculate it will be 5. So what we will find? The manganese as a reduced oxidation number of manganese is reduces. So it will be the oxidizing agent. Whereas bromine you will find that is increases. So it is a reducing agent. So first thing we have done that identify the elements whose oxidation number has changed. Here manganese and bromine, both the element has changes the oxidation number. After that, what we have to do? We have to calculate the second step. The first step we have already done. Second step, what we will do? Now, which is oxidizing agent and which is reducing agent. So, oxidizing agent here you can easily understand. Permanganate ion is an oxidizing agent because its oxidation number is decreasing. The MnO4, the plus 7 in the manganese, and it is decreases to manganese oxide, and there is a total increase we can see because one atom is involved here, one atom, that is total increase is equal to C, that is 3. Total decrease in the oxidation number, total decrease, right? Total decrease is equal to 3. Okay, for the bromide ions you can see it is bromate ion, it is from the bromate ions, and here you can see total increase minus 1 to plus 5. Total increase is equal to, that is how much? 6. Then we have to equalize the total increase. Equalize the total increase and decrease. How do we do this? Here you can see increase in total increase is 6, whereas total decrease in 3. So what we will do? We have to multiply this manganate ion. We have to multiply plus Br minus is equal to 2 MnO2 plus bromate ion. So now you can see that here from this equation we have balance, we have equalized the total number of increase in the oxidation number 6. Here is higher, so where total number decrease was lower, that we have increased it by putting this multiplication factor. Then what we have to do? We have to equalize the charge. Now we have to equalize the charge. That's what we have to do here. Equalize the charge. In this reaction, in this case, we have equalized the charge. Now same thing we will do. What we see, first we understand what is the charge in the left hand side. It is the minus 3 and the right hand side is a minus 1. And in this point we have to note one very important thing. That is, as the reaction is carrying out in the basic medium, so we have to balance the charge with the OH minus ion. So OH minus ion is the negative ion. So we have to put one OH minus ion or 2 OH minus ion, because this is a 3 minus 3 charge. It will give 1 minus 1 charge because this is a neutral molecule. So what we will do? 2 MnO4 minus plus Br minus is equal to 2 MnO2 plus BrO3 minus, we have to put 2 OH minus. Okay, so now we have balanced the charges. Now what we have to do? We have to balance the hydrogen atom. How do you balance the hydrogen atom? We have to put the H2 molecule. So you have to put 2 H2 molecule because there are 2 hydrogen atom. So we will make it 4 Br minus plus 2H2. That it will give MnO2 plus Br3 minus plus 2OH. Now we can see this is a balance equation. What will we do? We have to now count. Manganese 2 atoms here and here is 2 atoms. Oxygen you can collect, that is 8 plus 4 14 and 8 plus 4 12. Here you can see 4 plus 3 7 plus this is 4 plus 3 7 and this is 2. Total 9. Here also you can see it is a total equation is the, so here you can see that oxygen is balanced but hydrogen also balanced, because in the hydrogen you can see so here you can see the oxygen here in this oxygen atom how much? That is 8 oxygen here is 10 and here you can see oxygen that is 4 plus 3 plus so here what we will do, we have to put one H2 only, not 2 H2 to balance it, because there is a 2 hydrogen atom, we have to balance the 2 hydrogen atom by 1 H2 molecules. So this will create, now you can see 6 plus 8, this is 8 plus 9 and here you can see 4 plus 3 plus 2, total 9. This is 9 molecules and here is 9 molecules and hydrogen is already balanced. And that will see the balancing of this redox reaction. So in this way we can able to balance the reaction by oxidation number method. What is the steps? That steps, there is no difference in the steps, only if we see the acid medium or the basic medium, only difference when we balance the charge. In case of acid medium, we have to balance the charge by H plus ion. In the basic medium, we have to balance this charge by OH minus ion. Only difference in this, and after besides this, all other things are same. There is no difference in this. So balancing by oxidation number method that we have discussed, you can practice from your textbook or from other books some other examples that it will give you much more clarity and confidence. That is all for today's lecture. In this lecture we have discussed about the balancing of the equations, chemical equations regarding the redox process by oxidation number method. In the next chapter, in the next lecture, we will going to discuss another method, that is the half reaction method. If you like this lecture, you can share to your friends. Thank you for watching.